Okay, I'm gonna now show you the lesson on cubes. So say the child has been doing a little bit with squares of numbers and that seems to be comfortable for them. I would think that they would be all like, okay, I get it, maybe around 8, but 7, 8, maybe 9, depending on the child. And they would be ready to go on to exploring cubes, but it just depends on their comfort level. Okay, so you could introduce cubes pretty early on, maybe 2nd or 3rd grade. However, for them to there'll be some other lessons on cubes, so this is a very sensorial beginning. They'll get more comfortable. I wouldn't expect them to master all the cubes of numbers right away, but by the end of elementary, they should be really comfortable with them. Okay, so we've got all our squares for this one, all the squares that go with it, and we have the long chain. You can review that the short chain folds up into a square, just as a review. Okay, like, oh, do you remember what shape the short chain folds into? That's right, it folds into a square. Now, I want to show you something interesting about the long chains today. You could do this with any, but I like the 3 because it gets the point across without being huge numbers, and then they can explore the bigger numbers on their own. And also it makes the shape really clear, but you can also use the 2 if you need a little bit of a smaller one. So we're going to fold the long chain into one square and then another square. So kind of keeping it separate. There's a bigger loop in between, which is partially because of this, to help you fold it. There's 2 squares in there. Let me try to make another square. Here we go. How many squares did I make with the long chain? 3, that's right. I made 1 square of 3, 2 squares of 3, and 3 squares of 3. Each one of these is 3 squared. Each one of them is 3 times 3. So I'm going to write, if this one is 3 times 3, because I have 3, 1, 2, 3 times. How many times do I have 3 times 3? Once, twice, 3 times. So I have 3 times 3 times 3. Another 3. Now, I can replace each of these squares that I made with the square that came with the cabinet. This square of 3, this square of 3, and this square of 3, to show you something else cool about the long chains. I can take this square of 3, stack it on this square of 3, and stack it on this square of 3, and what shape have I made? It's equal on all sides, right? Just like this cube. And you know what a cube is. You've seen other cubes. It's equal on all sides, like a 3D square, a 3-dimensional square. And just like we have a shorthand way of writing 3 squared, which we could use on a square like this, we also have a shorthand way of writing this. Since it's made of 3s, all the bars have 3 on them, I'm going to put a 3 on my piece of paper. 3. And when they were squares, we put a little 2 because it was equal to 3 times 3, which is 2 3s. And now the cube is equal to 3 times 3 times 3, which is how many 3s? 1, 2, 3. So I'm going to put a small 3. Yeah, 3 times 3 times 3. 3 with a little 3 on top. This is called 3 cubed. We can look at more of the long chains and see if we can make some more cubes and figure out if we can see if if we can figure out how to write them. And I wonder if you could figure out how many beads are in here. How could you figure that out? So at this point, I'd probably end the lesson. If it's super easy and they really got it, you might ask them to do another one, to show you one, or you can come back to that later, another time. Let them kind of absorb it, give them some time to explore, see if they figure out that, you know, the biggest ticket for this chain, the 27, is going to be the same as the number in the cube. And if they don't figure that out immediately, that's okay, because it can be another lesson for another day. But eventually you do want them to know that the quantity in this long chain is going to be equal to that, and let them see if they can figure it out or calculate it. 3 times 3 times 3 is 27. Okay, that's it for now.